And again, for A, you can stroke out the create the table of values. We're just going to quickly graph log base 2 of x, just like we saw in the previous example. Every parent log graph has an asymptote at x equals 0. Every parent log graph has the point 1 comma 0, and since the base of this one is 2, we have 2 comma 1. So there is our parent graph. Okay, and it gets too messy to graph things on the same one, so I changed the wording here. We're going to graph it on a separate grid, and so we want to look at this graph now in part B. We're going to graph y equals log base 2 of 2x minus 1. So what we have to see here is that this 2 and the x, they're part of your parent graph, right? This is your parent graph right here. The log base 2 of x is the graph that we have off to the left. Then we look, what are the numbers that are new? We have a 2 there. Can you see that that 2 is inside the function? Because it's with the x. That will be a horizontal compression. You will multiply your x values by a half. Is that minus 1 inside the logarithm? This can sometimes be a tricky thing to think about. In this case, it is not. If they wanted that minus 1 inside the logarithm, they would need brackets to put it inside the logarithm. So that minus 1 is a vertical translation. We are going to go 1 down. And we're going to do the same process that we did in our transformations unit. We are going to take our 2 points on our original graph, which are 2 comma 1 and 1 comma 0. We are going to do stretches and compressions first, then translations. So we need to multiply x by a half and then move 1 down. X by half will be 1 comma 1 and 1 half comma 0. Moving 1 down, we'll change this to 1 comma 0 and 1 half comma negative 1. And then we also have to look at our asymptote. And again, just like in exponential graphs, the asymptote was only changed if you moved it up or down. Can you see in a logarithmic graph, the only way you're going to change that vertical asymptote is if you move it left or right. In this case, we're moving 1 down, so our asymptote is going to stay. We can now sketch our new graph. Our asymptote stayed at x equals 0. Our new points are 1 comma 0 and 1 half comma negative 1. Label those 2 points. And draw the graph through those new points. Questions for practice on this one? 8, 9, 10, and 11. But before we end this video, we are going to do a couple more examples. I want you to first try these ones on your own. I'll put up the answer in a second. So on page 400, which is a blank page, I would like you to graph y equals 4 log base 3 of x plus 1 minus 5. If you want to check how you did, here is your base graph. Log base 3 of x has 1, 0, and 3, 1. And we look at the transformations. We have a vertical stretch, y by 4, horizontal translation, 1 to the left, vertical translation, 5 down. So if we look at our points and where they go, this time our asymptote's going to move. And then we label those new points and our new asymptote. And this is our final graph. Your parent graph, the natural log of x, has 1, 0 and e, 1. So we take our points, do our stretches and compressions first, translations afterwards, keep e in there as you go, and then when you go to graph, you have to graph 2e minus 4. You're going to just do a rough estimate. E is about 2.7. So 2 times 2.7 is about 5.4 minus 4. This will be at about 1.4. You estimate where that would be. Draw your asymptote and your final graph.